This part of the module deals with simplifying trig identities. So let me work a few examples for you, kind of show you how we're going to use our trig ratios to simplify some different expressions. So if we have tangent times cosine, remember tangent from the other part of the module, tangent's the same as sine over cosine. And then we just bring down that cosine. Cosine, cosine over 1, same thing. These cosines cancel, so tangent theta times cosine theta would reduce to sine theta. And that's what the problems in this module are like. You're going to simplify a trig identity to a single term. So, I mean, these get really hard, and I'll share some of those with you before I end this video. But this part of the module just kind of sticks with the simple trig identities, which is very good for online learning. It's very hard to teach this over internet and videos and stuff. So just look at a few more examples. Okay, so we got cosine. I'm not going to change anything there. Cosecant I can rewrite as 1 over sine, right? And then when I put these two together, I would get cosine over sine. And from the other module, we learned that cosine over sine is cotangent. So this expression here is equivalent to cotangent. So looking at a few more. And the problems you're going to do in the module are multiple choice. And they're all about this level of difficulty too. Okay. And I might need a little more room to do that one, so I'll scoot up a little bit. Okay, so let's rewrite some things and see what's going on here. Secant. I know secant is 1 over cosine, and that's kind of what you do. You just rewrite things in a different form and try to simplify. Tangent is sine over cosine. Okay, so this top part, sine times 1 over cosine is just sine over cosine. And I've got that same part in the denominator. So just using an algebra rule now, anything over itself cancels out to be 1. So this one reduces down to 1. So a few more here. Cosecant over cotangent. So let's think about how we want to rewrite this. I can rewrite cosecant as 1 over sine, because sine and cosecant are reciprocals. Over, I can rewrite cotangent as cosine over sine. And when you divide by a fraction, you're going to multiply by the reciprocal. And we've seen that play out a bunch. And these signs cancel, leaving 1 over cosine, which is just secant. 1 over cosine is secant, because they are reciprocals of each other. And I think I've done all of those examples that I had planned. Let's take a look at a couple of harder ones now. All right, so if you look on the trig identity formula sheet, and I'll pick a different color. If you look on that trig identity formula sheet that's uploaded in the module, you'll see these two identities. And you also saw this in the other video I put out, that this is a real popular trig identity. And we can, let's say we subtract cosine squared from both sides. You know, what would I have then? I would have those cancel, so I would have sine squared equals 1 minus cosine squared. So there's another identity all to itself. And likewise, if I subtracted sine from both sides, I would have 1 minus sine squared. So you got 3 versions of this identity that we just do simple algebraic techniques to. to solve it for something else. And so we do have some trig identities where you have to use this sine squared plus cosine squared equals 1 to reduce it down some. So let me show you a few of those and how they work. Take some of this off. Okay. So we'll start with this one. And these are a little bit more difficult. And remember, this module is all about reducing an expression to a single term. Okay? So 1 minus cosine squared is sine squared based on the identities we just had up. And we do nothing here. And remember, sine over cosine was tangent, so sine squared over cosine squared would be tangent squared. So there's the answer there. So a little more difficult. You just got to practice and get familiar with these trig identities. I'll show you one more with these trig identities. So same thing there and a different denominator. Okay, so this 1 minus cosine squared, sine squared. And I'm going to rewrite tangent, or rewrite tangent squared as sine squared over cosine squared. And when I multiply by the reciprocal, so I'm going to multiply by this reciprocal. And these signs cancel out, just leaving cosine squared. So be aware, I use theta a lot when I was working these examples for you. In your questions, you're going to see x instead of theta. Just 1 minus cosine squared x over cosine. So you're going to see an x instead of a theta when you're doing your exercises. Okay, so give it a shot. Let me know if you have any trouble, and I'll